All right, here we're going to look at example 4, solve a system of equations approximately. So we're given a system of equations, and conveniently enough for us, the two equations have already been isolated for y. So y equals 2x minus 3, I can type that right in the calculator. Don't have to move anything around. Pretty fortunate. Take a look at the graph. It goes from the bottom left to the top right. So let's now pull some points. All right, -1, -5 is the first one that looks useful based on the graph I have on paper. 0, -3, 1, -1, 2, 1, and notice that my slope is 2, so I'm just going to keep going up by 2 now. I don't need to keep referencing the chart, just make sure things are right. Yep, we're good. All right. Connect your dots, draw your line, and we have an accurate representation of our y equals 2x minus 3. So we're going to go back to y equals, and for the second equation, I'm going to do this one in red. Y equals -5x plus 6. You can plot this using the slope and intercept, which I've mentioned in previous videos, but since we're approximating using the graphing calculator, we need to type in the calculator anyway. So let's just go with that. All right, we have that. Take a look at your graph, see what it would look like, and then find your points. So first usable point would be 0, 6. All right. If I'm going through the points too quickly, just feel free to pause it and take a look at the coordinates and plot them. Well, that's not right. Something's not right here. I'm pulling the wrong points. All right, so 0, 6 is correct. 1, 1, sorry about that. 2, -4. I was using I don't know what I was using actually. And 3 is off our graph, so we can't use that. Let's try that again. Connect the dots here. Close enough. All right, so we do see that the solution is somewhere in this range. It looks like my x value is a little bit past 1, and then my y value is somewhere around -1/2. Okay. So to find these, we're going to use the graphing calculator to approximate the solution. If you go to the graph, our answer on the graph does look similar to what we have drawn, so that's good news. To find the solution, remember we have to trace or calculate the intersection point. So you're going to hit second, and then the trace button, which will bring you to the calculate screen. We're looking for the intersection, so go to option 5 and hit enter. Now it's going to ask for first curve. You can see that my cursor is blinking on the blue line. If I hit up, it'll go to the red, but we'll keep it on the blue one. That's my first curve, so I'll hit enter. Now it should jump to the second curve or the second line, which is the red one. If it does not, just hit up or down until it winds up on the red one. We'll hit enter again. And now it's asking us to guess. We only have one intersection point, so it doesn't really matter if we move the cursor or not, but I'll put it close to the intersection. This is not your answer, so you don't want to go with the numbers that are up right now. You need to hit enter, and now it'll say intersection. Those are your solutions. So we're going to say that x is approximately, does it tell us what to round to? It does not, so let's just go 2 decimal places. So 1.285, so I'm going to round that up to 1.29. And then for my y value, I'm going to say it's approximately -0.428, so we'll say 0.43. That does not look like a 3. Looks a little better. And then if we do want to write our final answer as a coordinate point, we would remind ourselves that this is approximately 1.29, -0.43. You may be better off in this case leaving it this way, because we are talking about approximations, but if you want to write as a coordinate point like this, feel free to do so. This is very similar to what we did in the last section, just finding the intersection point using the calculator. Okay, we're going to approximate it. That's it. Again, you should be familiar with this. This should be just a review. Oh, there you go.